All right, welcome back. We are going to switch gears and we are going to finish out the year doing stuff that's hopefully a little bit more familiar to you, volume and surface area. So we're going to start with volume today. We are going to talk about prisms and cylinders. All right, so a right prism has lateral edges. These would be our lateral edges that are perpendicular to the bases. So the two sides that are identical that it would sit on typically. All right, so a right prism, you more commonly know these as boxes. Packaging, most of those are right prisms. A right cylinder has bases that are perpendicular to its center axis. So that line down the middle is perpendicular to that base. So these are your typical cans, pop cans, soup cans. All right, so to find the volume of these, we are going to use the formula length times width times height. So this is otherwise known as the volume is equal to big B times H. So big B is simply the area of the base. All right, to find the area of the base, we take the length times the width. To find the volume, we take that times the height. All right, the volume of a cube is sometimes denoted as this, V equals S cubed, where S is the sides of all of our, is the sides of the prism. So since all of these are squares, they're all going to be the same, so that's where you get the S cubed. So the S times S times F, which equates to length times width times height. All right, so practice using these. All right, so we need to figure out which one is the base. So the base is going to have two identical shapes and only two. All right, so on this one, we could call any number of these our base because we are going to multiply in the same measurement. So if we call this our base, we have 2 times 3, and 6 would be our height. If we called this one our base, we would have 6 times 2, and 3 would be our height. Likewise with the top or the bottom, we would have 3 times 6 times 2 is our height. So property of multiplication, doesn't matter which order we multiply in, we are going to get the same answer. So in this case, we have 36 yards cubed. All right, if we look at a triangular prism, this time, okay, the triangles are our base. So we are given a right angle. Okay, so the area of our base would be 6 times 8 times a half, and the height of our prism is 5. So the only thing you need to be careful of here is which measurement they're giving you. In this case, they give you that extra 10, which we actually don't need. So this one, we calculate it out, we get 120 yards cubed. All right, next up we have another triangular prism. So this time our base is the triangle, call that the triangle, the base of the triangle. So we have a right angle, which means these are the two measurements we're going to need, which in this case are 4 and 3. And it's a triangle, so the area is half that. The height of our prism is 7. So in this case, we have 42 cubic feet. All right, so cylinders. Okay, cylinders is the same thing. We need the area of our base, which in this case is pi times the radius squared. We talked about that already. So the volume of a cylinder is the same thing, pi r squared times the height. So that pi r squared would be our big B in the equation. All right, so in this case we have our diameter, which is 10. So our radius is that divided by 2, which is 5. So to find this one, we're going to take pi times our radius squared times our height, which is 7. Okay, pop that into your calculator. You get 549.5 cubic feet. All right, oblique prisms and oblique cylinders. So this is just essentially a slanted prism and a slanted cylinder. So the axis is not perpendicular to the base in our cylinder, and instead of being rectangular, now we've got parallelograms in our prism. All right, so we're going to use Cavalier's principle to find the volume of these. So what Cavalier's principle says, if two solids have the same height and the same cross-sectional area at every level, then the two solids have the same volume. So in this case, for example, I have a stack of 5 coins here. And if I take those coins and I slant them, my volume is not going to change. So this blue line, as you can see, the height of the stack of coins is the same even when I slant them. So if I drew a cylinder around this stack of coins, okay, it has a volume of 5 coins. If I take this oblique prism, you notice it's still a volume of 5 coins. So how I find the volume of these is the same. I take the area of the base and times the height. The only thing is you need to make sure that you're finding the right height, so the height with a right angle versus the slanted height. All right, so practice with this. So we need the area of our base. We're given the radius is 12, so this is 12. So 12 squared times pi, and our height, this, they give us as 45. Okay, so if we calculate that, we get 20,347.2 cubic inches. All right, well, what happens when they're not given the height? Right, I need this dimension, which I don't have, but what I do have is a right triangle. So I have this right triangle with 2 measurements. So Pythagorean theorem. So 17 squared minus 14 squared. 17 squared is our hypotenuse. Minus 14 squared, and the square root of that will give me my height. Which ends up being approximately 9.64 centimeters. All right, so to find the volume of the cylinder, so the volume is pi times the radius squared times our height. So our radius is going to be 7, so 14 divided by 2. So 7 squared times pi times this 9.64. And you will get 1483.2 approximately cubic centimeters. All right, so you're just going to take what you know, find what is missing to find the volume. So a lot of this will be Pythagorean theorem, using all those pieces that we've already done to find volume of obliques. I think most of the problems that you have, you're actually given the height, so don't have to worry too much about that. And that is all for this week, and we will see you later.